Hi, my name is Dave Cleland. I'm with MBSI WAV, and welcome to Tech Talk with Dave. Today we're going to talk a little bit more about the mystery of the virtual local area network, or VLAN, in layer 2 networks. We're going to take a closer look at the standard. We're going to take a look at the application of the standard 802.1p and q, and we're going to look at typical uses and maybe some abuses of what these 4 little octets in the Ethernet frame can do for you. All right, so in review, we can remember what the Ethernet layer 2 frame looks like. So we have anywhere from 64 to 1522 octets that make up the frame. Of these octets, we have 4 that are used to generate what's called a VLAN tag. So we have, you notice down here the 802.1q format is 16 bits long, of which 12 bits we use for the VLAN tag itself, and then we have an ether type that identifies where this is, and so tells the receiver of this frame what to do with it. 802.1q, it's an optional 4 octets before the payload. This is important. It's before the payload. So the 12 bits of address give us 4,096 possible choices. VLAN ID 0 and VLAN 4096 are reserved, so therefore our allowed VLANs are VLAN ID 1 to 4095. The rest of the 4 octets are used for the priority, 802.1p, and the allowed values are 0 through 7. So we can take and put a priority on this frame, and we can take and put a VLAN tag on this frame. Why would we do that? Why would we put a VLAN tag on the frame? So its primary use is a filter. It's important that it's before the payload in the Ethernet frame, because we can have our device filter on that VLAN itself. So let's suppose, again here in my pair of routers that I've got here on the table, that I'm going to configure my second router so that it must only will react to VLAN ID 100, for example. So out of the first router, if I transmit data without a VLAN or data with a different VLAN tag, what happens here is that the Ethernet port on the second router will see that frame, and it only has to decode to the VLAN tag. And then it knows that the VLAN tag is either right or wrong. If the VLAN tag is right, of course it continues to process the frame. If the VLAN tag is wrong, well then it just simply discards that frame. So using VLANs in a broadcast, in a layer 2 network like this, will take and enable us to reduce the size of the broadcast domain, because I'm not responding to every bit of traffic that comes on this link. As a matter of fact, if router 1 here sends out a broadcast to the network, and router 2 happens to be on that network but it's looking for a VLAN, that broadcast has to have the VLAN tag in order to be received by the other device. So I have a very, very easy way to filter my traffic that without having to change the IP address, without having to limit the IP addresses. So its primary use is a filter. There are 3 modes that VLAN devices operate in. One is called the hybrid mode, where all frames can pass, whether it's got a VLAN tag or not. And we see this configuration on switches, we see this configuration in radio devices, we see it all over the place. Hybrid mode. All frames can pass. We have a trunk mode, where only properly VLAN tagged frames can pass. Well, maybe all VLAN tags can pass. Depends on what the mode is. So in a switch, it's possible to put the switch into trunk mode, and then if it's got any VLAN tag, it's going to process that VLAN tag. If it does not have a VLAN tag, then the switch will drop that frame. And then finally we have access mode. That's where untagged frames from the that are transmitted from a device are received by the second device and converted to a VLAN tagged frame inside the device so that it can be processed. Maybe the VLAN tag is then propagated onto the network farther on, whatever the case happens to be. So a VLAN tag is added. In the other direction, the VLAN tag is removed from the Ethernet frame, and the frame is transmitted with without a tag to the rest of the network. This is often used where, for example, let's say I've got a Wi-Fi access point. The Wi-Fi access point's only got one SSID in it, so I don't need a VLAN for that. I can take and transmit from my switch to the access point. Maybe I use PoE power and I power my access point up. But inside my network, I want all that Wi-Fi traffic to be on VLAN 100. Again, let's say it can be any VLAN ID. And so all of that traffic inside the network, the port has to be ready for that VLAN tag 100. If it's not, if the VLAN tag is different, then the network is going to process that frame differently. But when I leave my switch or my router and I'm heading towards my access point, my frame has been stripped off. So I got the three modes: hybrid mode, all frames; trunk mode, only VLAN tagged frames, and only recognized VLAN tag frames, because you can set them to set the port to limit or not, generally speaking on devices. And then the third mode is access, where I go from a tagged situation to untagged or untagged to tagged. So here's a kind of a typical VLAN example. I've got a network that spans a couple of floors of a building, floor 2 and floor 3 in this case. I have computers that are connected to the network on various ports of the switch on floor 2, and I've got computers connected to various ports again on the switch on floor 3. In between the floors, now I have a single connection between these two switches. But inside of that single connection, I want to take and make sure that that ports on the floor 2 switch, ports 2, 3, and 5, connect to ports 2, 4, and 6 on the third floor only. I don't want ports 7, 5, and 3 on the third floor to receive any of the traffic from that's labeled in the blue VLAN. So what we have is we've got two VLANs that we can use here, and we can take then and the devices, the switches, and the computers themselves are looking for a particular VLAN, and the switches will take and drop the frame if the VLAN ID is wrong. So in my case of ports 2, 3, and 5, maybe those are access ports and they get converted to VLAN ID. In this case, I've got VLAN ID 1. VLAN 1 can be tagged or untagged. It depends on, we'll talk about that in a minute. But anyway, so I've got a VLAN ID. Ports 4, 6, and 7 on that switch, different computers connected to a different VLAN, VLAN ID number 2. And so then that is any traffic that's going to the third floor will then be on VLAN ID number 2, and when it gets to the switch will take and know that it's connected to the computers that are on ports 3, 5, and 7. So this is a pretty simple network, but we see this example oftentimes in the broadband world, where we've got maybe management. In this case, the VLAN 1 that's enabled for engineering could actually be network management, and VLAN number 2 that's for marketing, well, that could be your subscriber traffic. The internet could be on one of the ports of floor 2. So then we use the VLAN to filter the customer traffic out, and we use the VLAN and the customer traffic to filter the management out, so the two do not mix with each other. So in the network configuration choices, if the computers were not VLAN-aware devices, then on floor 2 switch, ports 2, 3, and 5 would be configured as access, as I mentioned. The ingress traffic would have VLAN ID number one for engineering, whatever that value is, added to the frames, and on egress, or leaving the switch, VLAN ID 1 would be stripped off. If the computers were VLAN-ware devices, then floor 2, ports 2, 3, and 5 could be configured as trunk ports, passing only the right VLAN frames for that particular computer. All the other frames would be dropped. So you can see that by doing this, we can take and improve the performance of the switch by limiting the amount of traffic that it has to process. It only looks as far as the VLAN ID on the frame, and it can determine whether I got to continue to process that frame or whether I can just throw it away. So other common VLAN applications. I've used an example of a Cambium PTP820. The requirement is that the default management IP has got to be reachable for emergency recovery and restoration, but a local connection only. The local management IP on this radio, as well as the management IP on the remote radio, has to be reachable on the same port as the traffic passing over the point-to-point link. But I don't want that traffic to mix. So what do? I take and I put the subscriber traffic over this link in a unique VLAN, and I put the management over this link in another unique VLAN. And so when I do that, the system will take and only allow VLAN ID 100 to go to devices that I deem as management, and VLAN ID 200 will only go to devices that are deemed to be subscriber traffic. So again, I built this filter network that keeps the two types of traffic out of each other. And then in the third case here, my local management, there's no VLAN tag on it, and so I can just take and connect it to any computer locally and log into the radio and do whatever work I need to do on that particular radio. But the device management traffic, let's say, is the red arrows here. In this case, I can take and remotely manage this system from my NOC, or my data center, my central office, whatever it happens to be, and be able to manage both ends of the radio. Whether my connection to the radio is fiber or whether my connection to the radio is Ethernet, Cat5 I should say, or twisted pair, it doesn't really matter. So here's a typical fixed wireless network layout where I've got a core, I have backhaul to my point to multipoint APs, and then I have a subscriber module that is connected to the tower, and then that goes to my customer location. Well, that subscriber module, maybe I've got 3 different kinds of traffic that are going to it. So obviously I have network management, which again is the red arrow. I do not want the network management to proceed beyond the subscriber module. I want it to stay within my network so I can manage the devices that are along the way. My internet service, yes, I want it to go all the way to the end, so it comes from the cloud and ends up on the second VLAN across my network. I set the system so that the second VLAN is delivered to perhaps a router or the computer equipment that's at the subscriber. And then I have a third service on here, which is a VoIP service, which voice over IP, which again comes from a different IP network that's out on the server that delivers this voice service is sitting on. I carry it separately across the wireless network, across the backhaul, across the wireless network. That way I can take and specify its priority. I can give it a higher priority than the best effort internet traffic that's carrying along with it. Arrives at the subscriber module, and I can deliver it then to the phone equipment or the TV equipment, depending on what I need to do. So that's a typical use of VLANs within a network. And you can see the only routers that we have in this network are the routers that are in the core. And so then after that, we are layer 2 all the way out to the subscriber. But the subscriber traffic is filtered. So in a normal layer 2 type of network, that subscriber would be able to see all of the different services that are on the network. But because of the VLANs, they cannot. Any questions, any comments, any feedback that you have, please send an email to marketing@mbsiwave.com and we'll be happy to comment. If you have new topic suggestions, send them to marketing@mbsiwave.com also. And who knows, maybe the next Tech Talk will be the topic that you suggested that we do. So have a good day. Thanks.